Following is true in modern bipolar junction transistors. So if we look at page 103 in the notes linked below the like button, we'll have more information about this. So modern bipolar junction transistors. This is the important part. It's a bipolar junction transistor, which is a BJT. So that means we're going to look at the BJT notes in the description below the like button. And we're going to want to look on page 103, this section right here. The first one says the base doping is much higher than the emitter doping. So base doping much higher than emitter doping, and this is to minimize the number of carriers injected from the base into the emitter. So if we look here, we can see to keep the base current small, the base must be narrow to minimize recombination in the base. Also, the doping in the emitter, which is what we're talking about right here, base doping in the emitter, is greater than, much greater than, the doping in the base to minimize the number of holes injected from the base to the emitter. So this is incorrect by itself. It says carriers. This should be the number of not carriers, but the number of holes. So we should have holes here injected from the base into the emitter. So the rest of this is correct, but let's look at this first part. The base doping is much higher than the emitter doping. Well, it says the doping in the emitter is much higher than the doping in the base. So these are backwards, meaning that this one is going to be incorrect. Next, we have B. Obviously, it cannot be B. We're going to look at C. The base is kept wide to minimize recombination in the base. Let's look at this. So to keep the base current small, the base must be narrow to minimize recombination in the base. The base must be narrow. And it says the base must be kept wide. So this is incorrect because it needs to be narrow. So this is wrong. Next, we have the minority carrier concentration in the base decreases almost linearly from the emitter to the collector. And we can see this from our diagram right here. It's saying the minority carrier concentration, so this part is important, in the base, it's going to be decreasing almost linearly from emitter to collector. So if we look at our diagram, minority carriers and forward active, it looks like we're doing good so far. And it's in the base decreasing almost linearly. We're going from emitter to collector. While the emitter is right here on the left, collector is right here on the right. We can see it decreases almost linearly in the base. So D is going to be true. Next, we have carriers diffuse across the base and are collected by the emitter. Well, if we look at this, if we scroll up, because these aren't the only notes we have some more right here, NPN in the forward active region. Electrons are injected from the emitter into the base. They diffuse across the base and are collected by the collector. So here it's saying carriers diffuse across the base, collected by the emitter. It's really wrong because we know that they are collected by the collector. So this part is incorrect. It should be the collector. Now let's look at the first part. Carriers diffuse across the base. This is true. They do diffuse across the base. They are just not collected by the emitter. They're collected by the collector. And that's how we would go about solving for this problem using the notes that are linked below the like button in the description.